Hello, everyone. Welcome, CoffeeJug community, and welcome, Ronald. Thank you for joining today's event. And Ronald will share today insights about JobRunner and how easy we can start background job processing in distributing environments in an easy way. And Ronald, basically creator of this tool, pretty nice tool. I want to share that I've used it in multiple projects, and it's pretty nice. Yeah. So. It will be amazing to hear from the creator. And welcome everyone who joined today. Welcome to CoffeeJug event. And I want to remind that we can organize this event and discuss some technical topics here together. Just because of armed forces of Ukraine, because of they standing and fighting against Russian aggression, and of course, every day we should support volunteers, armed forces of Ukraine, and everyone who are standing. And remember that there is no small donations, there is no small help, and try to help as much as possible every day. So thank you a lot. And of course, about our community, the main goal of these events to grow Java community and to learn something new. And today is 16 events and more than 700 participants during all the times that we have this event. That's pretty nice. And let's not forget to join these events and learn something new together. Also want to say thank you organizers team of CoffeeJug that behind the scenes trying to invite new speakers, organize these events, and makes everything happen. Thank you, guys. And of course, want to remind that this year we'll have a Java Day Lviv on July 4. So I would like to invite you to this event. This year it will be a fully online and free to watch. Of course, the only pay that you should do is to small donation or a big donation. It doesn't matter to any fundraising that you know. Also, if you want to join this event as a speaker, please scan this QR code and request, propose your talk that you want to share, so to have a chance to become a speaker at this event. And join us in the social media to do not to follow us and join the social media so you can join our future events. Yeah, don't miss it. And go ahead, Ronald. Happy to hear something interesting from JobRunner. Yeah.
All right. Thank you. Really, indeed, thanks a lot for inviting me to the whole organizing committee. And this talk is in fact a talk I gave at Devox. It's a JobRunner deep dive. So it means that we are going to really go into the internals of JobRunner, but also of Java. By the end of this session, you will know how to read bytecode. And trust me, it is really not that hard as you think it is. And why, I will explain everything why. So yeah, what let's dive into it. So JobRunner is an open source library, and I created this quote back in the days. It's now 4 or 5 years ago. And I called it the ultimate library for background job processing in Java. It's distributed and backed by persistent storage. And of course, it's open and free for commercial use. But of course, I'm biased. Don't buy it from me. I created it, so of course I will put something nice. But I was really, really lucky that a couple of years ago, ThoughtWorks put JobRunner on their technology radar. And I think ThoughtWorks is quite known in the tech world. They are like the Gartner from software, and they mentioned that their teams are enjoying using JobRunner and the built-in dashboard. But yeah, that's just nice. The quick agenda for today. I am curious I am first going to introduce myself, and then I'm also curious who you guys are. So via the chat, please say if this is your first time or not. Afterwards, I will watch it. So I'm really curious if the amount of people that joined grows here. And then I will explain why I started JobRunner. Then it is time for some live coding. I will do live coding on how to use JobRunner. Then we'll discuss the internals of JobRunner. So how does JobRunner work? So if you want, you can build your own JobRunner. Then we'll discuss where we are today and tomorrow. And then there is time for Q&A. And yeah, the eating my own dog food is in fact talk is cheap, show me the code is in fact the same thing. So I will do, that's the live coding, but I will do it in step 4. So who am I? I'm Ronald. I have 3 kids. I'm a big fan of Pevo, I think it is, beer in Ukrainian. And I'm really happy to be born in Belgium because I think we have more beers in Belgium than we have, more types of beer in Belgium than we have inhabitants. So that's a really, really good country to be in. And here is a picture of Duvel. It's one of my favorite beers. And then, yeah, who are you guys here in the session? Are there any first-time attendees? Just type first time or the amount of time that you joined. And then, do you know JobRunner? Type JobRunner known, yes or no. And are you already using it, perhaps? So then you can also type JobRunner instead of known or not known. You can say using it somewhere, like Ole. Voila. Then I know afterwards how many people already knew it and how many new people I could introduce to the tool. But now let's go into the reason I actually started JobRunner. And that's because 4 years ago, I was freelancing here in Belgium. And I was asked to join a new assignment. And they mentioned, yeah, there is this Greenfield project in FinTech. And notice the quotes around Greenfield project. And what they were building was, in fact, e-invoicing software, so a gateway to the PayPal network. And I don't know how it is for Ukraine, but as of next year, here in Europe, everybody will need to send their invoices via XML digitally, and PDF will only be allowed as a base64 attachment within the XML. So just sending a PDF invoice business to business is not allowed anymore in Europe. And so what they were doing, they were building a gateway to the PayPal network. And then so what is PayPal? PayPal stands for Pan-European Public Procurement Online. And that's perhaps also the reason why all these people in the European Parliament here in Brussels make too much money. They can come up with difficult names that for easy things, in fact, because PayPal is just e-invoicing or the e-procurement standard for Europe. And yet this long sentence, I don't know why they came up with it, but yeah. And of course, since it's PayPal, everything is XML based, because who doesn't love XML? And when I arrived on the project, it was a microservice party. So there were a lot of RESTful microservices on Google Cloud. And they offered an asynchronous API to their customers, so people could send the XML invoice. And the first thing that was done was we saved the XML, and then an event was put on PubSub for further processing. All other communication internally was RESTful, so even external APIs. And the goal was, of course, to process millions of documents per day. But yeah, it's been a while. I don't know how many that they process now. But the last time I checked, they were only processed 100 documents per month. So yeah. So, but main thing to remember here is, I think there were more microservices than team members. And then, yeah, we started testing this, and yeah, things were not always so nice. Processing was not always retried on failure because, yeah, the internal communication between the microservices was using REST or HTTP. And yeah, when it fails, it fails. It was not retried. There wasn't any monitoring. Logging was done without a correlation ID, and invoices just got lost. The messages accumulated on the dead letter queue, which we didn't watch back in the time. So this was the Greenfield project I thought I would be joining. This is how I felt after 2 days in the project. I'd seen better projects already, to be honest. And then I considered a career change, but that's just not who I am. So I started looking into other solutions. And they are either vendor specific, so like AWS, Google Cloud, and back then there may have been even discussion about moving away from Google Cloud because the bill was so high. They often require extra infrastructure like Apache Kafka, Hadoop, Spark. And now it's become quite easy to install these kind of things. But back then, installing Hadoop FS was not that easy. And there was, from my point of view, no open source one-stop shop that is easy to use, distributed by default, that uses your existing infrastructure, so also your existing database, that includes monitoring, and that has resilience built in. And I really believe, that we're not all working for Facebook, LinkedIn, or Netflix, and that we need to process petabytes of data per day, or is it maybe hours? What I do believe is that we often need to solve complex business processes with a moderate amount of data, like maybe terabytes or something. I also believe that we need extra infrastructure just to do some distributed background processing. Let's keep things simple and stupid and reuse proven technologies like SQL and NoSQL databases. I think that creating and running these jobs should be fast and easy. And failing jobs should be retried by default and only bug me or warn me if they don't succeed after a while. It should be resilient by default. I also wanted to have instant insights whether this processing is all working fine. And such a tool should be self-maintaining and be plug and play. And these were the beliefs that I used when I started developing JobRunner. And each time I touch it, it's still, I try to keep true to these beliefs. So then, and this is small anecdote, by the way, this was right before COVID. So I quit the project back then, and I said, okay, look, I've seen this happen too many times. I want to solve this. So I quit my job. Then the whole world goes in lockdown. To be honest, I was really, really scared because the thing I thought was, oh no, will I ever get a job again? Because everybody's like, but luckily everything turned out fine. And then I tried to make it as simple as possible. Just use Java 8 Lambda to create a background job. It's distributed and cluster friendly, so cloud native by default. It uses your existing infrastructure, so your SQL or NoSQL database. You just need to add one dependency. I will show you in a bit when I do the live coding. It's resilient. When something goes wrong, it will retry automatically. And there is a dashboard, so you have monitoring included out of the box. And of course, it integrates with the best, being Spring Boot, Micronaut, and Quarkus. So here is the JobRunner, and this is all that you need to create a background job. What you do is you call backgroundjob.enqueue, and then you just give it a lambda. And this lambda will then be analyzed, and it may run on the same server depending on your configuration, or it may even run on a totally different JVM somewhere else. So, and that's the dashboard I mentioned that comes out of the box with it. So, So I think now it's time to do some live coding because we're all among developers here and talk is cheap. We all want to see some actual code. So I'll switch to IntelliJ. You guys are still seeing IntelliJ, I hope. If not, shout out. And I will start with a blank project. I am going to, however, go for Java. I will call this CoffeeJug, and I will increase the font size in a bit. Maven, create demo. Up, should be good. Theme light, and this should be already better. And then zoom. Let's make it a little bit bigger. Is this readable for you guys? I'll make it even bigger. That way we're sure. Okay. The first thing that I'll do is add some dependency. And I'm keeping this example as easy as possible. That way, whether you're using Spring Boot or Micronaut or Quarkus, we have integrations with all of them. Your life will be even easier. But what I will now do is just a standard Java project where we'll add JobRunner, and then I will configure it all by hand. So that's in fact what's happening behind the scenes if you are using the starter or the one of the integrations. So let's add dependencies. Dependency, we do JobRunner. JobRunner 751. This is the latest version. And we use JSON quite a lot. Why? I'll explain you later. But you need to either have JSON, JSON from Google, or JSONB on your class path. And now with the new version that we're about to release in the coming weeks, I hope, we also support Kotlin X serialization. So if you're a Kotlin fan, we've got your back too. So I will, in this case, add JSON data bind. Latest version also. And then last but not least, I want to have some logging also. So I will add logback core classic. And also this version. I hope that I'm not forgetting anything, because the live coding is always a little bit scary. That's why I typically call it mob programming. If you see something I'm doing wrong, just type it in the chat, and then Oleg or so will mention it to me, and that way I hope I can fix it in time. No, we want to create a class we are org.demo.coffeejug.main. And then we are going to do really, really basic stuff to start with. And the first thing I'm going to do is initialize JobRunner. So what I do is I type jobrunner.configure. Then for this demo, I will use the in-memory data store, but of course you can connect to, for example, a SQL database or MongoDB. But for the demo purposes, it's easier to just use the in-memory database. New in-memory storage provider. Then, of course, we want to have job processing available. So I will say we want to have the background job server. I also want to have a dashboard that we can see whether things are going fine. And then we just call .initialize. And this, in fact, returns two things. And I will get back to it later. But from this, we will need, in fact, the job scheduler for now. And we assign that to the job scheduler. And now I think like everybody, at least most projects that I've seen, they have some kind of service inside their project. So let's create a services folder, add some class called my service. And here we want to have a method, for example, public void do work. And doing some work with input plus input. And let's say that from this method, we would like to create a background job. Well, then what we go back to here, and we have our job scheduler instance available. So what we can do is we can do job scheduler, and then we need to pass in a lambda. But of course, we need an instance of the service. So I will just do my service, new my service. In fact, if I'm 100% correct, I don't even need that. What I can also do is use generics, my service, and then I can just call x, and x will be an instance of my service. And then I can do x do work, and I just say, for example, hello CoffeeJug. Let's run this already, and let's see what happens, whether I did not make any mistakes. All right. As we can see, things went really fast. Here we already have the output, so the job worked. And if I go to the dashboard, oops, yeah, this is Home Assistant, and I go to localhost 8000, then you should be seeing the JobRunner dashboard that I also launched. And by default, yeah, currently there is no work to be done anymore. We have the uptime. We see how many servers participate in job processing. But if I go to succeeded, I see here that this job actually succeeded. It succeeded 50 seconds ago, and 1 day from now, it will go to the deleted state, and then afterwards, it will automatically be deleted. But JobRunner can do a lot more. Let's go back to the service. Who likes exceptions? Probably, I'm a big fan of exceptions, so they show me, at least if the exceptions are good, they really help me solve the problem really fast. So let's say, for example, that this throws a new runtime exception. Another service is down. And we just start again. Voila. Here we already see, oh, something is going wrong. The service is we see the exception. But the nice part is that now and I'm going to open this window here that I don't, no, it's opening here for some reason. Can I do it here? Yeah. That way I'm not always switching back and forth. What I now see is that the job is now here scheduled in this case. Why would that be? And then what JobRunner does by default is it sees that an exception happened during the performance, during the actual performance of the job. And what we do by default is we retry up to 10 times with an exponential back-off policy. So in the beginning, we really try a lot, quickly one after the other, but the longer it takes to fix the issue, then we try less intensive. And this screen is auto-updating also automatically. So like before, it was just retry 2 failed, but now we already see here retry 3 of 10, the job got enqueued, and normally, I think any minute now, voilà, there, processing job, and it again failed, of course, because we keep on throwing that same exception. But what if you do not like to have 10 retries? Well, also there we have your back. You just say retries, and by default we it's 10, but here you can say, I only want 3. And the thing is, you can also give your job a name here, which makes it easier to find in the dashboard. So my service doing some work. And you can even add parameters here from the from the method that you're calling. So if I do %0, what does it mean? Well, JobRunner will call the toString of the 0th argument, the first argument, in fact. And that's what we will print here. So voila, let's try that again. It doesn't work. This is still the old one, scheduled hub. Here we now see my service doing some work. Hello, CoffeeJug. It's also visible here. And yeah, we see now that we will only retry 3 times. But we can do more. What if, for example, instead of directly enqueuing the job, you want to schedule it somewhere tomorrow or something? Well, we also have the method jobscheduler.schedule, and there you can pass in an instant, yeah, a lot of stuff. I'm going to use the instant instant.now and then plus 2, show no unit hours, and then again we just pass all of this. And now it complains, hey, it says, I don't know what X is. Well, it's because we didn't specify my service. And now this is solved. So let's make this a little bit more readable for everybody. Because, and this one we don't need anymore. So what we now do, and this is, for example, let's say you have an e-commerce website, and after a couple of days you want to send users that subscribed an email. Well, then you can just say, hey, jobscheduler.schedule, and then when you want it to happen, and you just, again, give your Spring Bean or your Quarkus singleton the work that the input that it needs to do, and JobRunner will make sure that it will happen at that moment. And even if you have 10 servers all running your same code because you're in the cloud or you're in Kubernetes or something, and multiple instances are running, well, JobRunner will make sure that only one server will perform that one job. So the same job will the job will happen only once. It will not be happening on each and every server. So let's run that again. If we now go to the dashboard and we go to scheduled, well, what do we see? The job now is just scheduled. We see that it's scheduled at this moment, and it's 2 hours from now. And of course, no exceptions because it's not running yet. And then we get to the last part almost of the demo. Let's stop this again. Sometimes you want to schedule something recurrently. Like another project where I could really use JobRunner was a project where we had to calculate the wages and this, or create the salary slips of a large part of the Belgian population. And there, at the end of each month, we had a job, and that job could then look at, okay, who are all the people that work this month, and then create, do the calculation, how much money they earned, create a PDF, and send it out. But then you need something that runs at the end of the month or at the beginning of the next month. And what you can do in this case is, again, jobscheduler.schedule recurrently, and then you just give a cron as so the cron expression and a lambda, or you can also do it, for example, with a duration, meaning that it will happen every, for example, 4 hours exactly after the previous one finished. Let's use the cron one for now. And to be honest, I'm not a big fan of cron expressions. I find them really, really difficult to write. So we have created a really easy utility method, and you can just say, I want to run it daily, which means it will run each day at midnight. Or I want to run it daily at 10 o'clock, or even 10 o'clock and a certain minute. But now let's run it. It's 6 p.m. 32 here in Belgium. So let's do cron daily 18.35. Oops. And then again, I will now do it another way. So my service. This could be, for example, a Spring Bean that you just have access to. And then you can just also do my service, .do work. Hello again, this time recurring. If I now run this, and we again go to the dashboard, then we will see that we have a recurring job here. And that recurring job, worried because the counter doesn't, there is the counter. That recurring job, well, it will run 1 minute from now, and you can even have recurring jobs, and you can put the different time zones. So let's say that you want to run jobs at 6 p.m. Ukrainian time, but you also want to run jobs 6 p.m. Belgium time. Well, that's also all possible. You can just go to here, and you can also pause, if I'm not mistaking, the zone idea. So the time zone in which you are, and then automatically it will show it in the dashboard and run it on the current time. If we then go back to the jobs, did it run already? No, 23 seconds from now, but yeah. Although this is a demo, this will go fine. So 15 seconds from now, the job will actually run. Let's wait for it. I don't know if there are any questions about this already, but that's in fact the live coding demo from JobRunner. And here now we see the counter 1. It's in queued. And of course, it starts failing again because we throw an exception. So that ends the live coding part. Let's continue with how JobRunner works internally. And then now I need, there it is. I need to close this. And we go to this part, the internals of JobRunner. And I hope you don't mind learning some stuff about bytecode, because that's what we're all going to do today. But first, how is the architecture of JobRunner? Well, what you saw me do earlier on, that's on the server. Now everything is in one server, but that's because we enabled the background job processing and the dashboard. But what you can do, just using configuration, using parameters for your pods, you can have here the possibility to just create jobs, and then you have X amount of background job servers that will do actual processing of the job. So what then happens is, well, the job is saved as fast as possible to the database, and then we return. And that's ideal, like in e-commerce systems of everything which is online, that we don't block the thread that is creating the job or doing. You want in the web part, you want to be as fast as possible. So what we do is we save the jobs. And then there are 1 to n different servers that can check, hey, is there any new work to do? And if so, they will pick it up and start processing it. And whether it succeeds or fails, in the end, they save the job state and then they immediately take the next job. And this allows us to scale horizontally. And we have a customer who has, I think, 40 different background job servers that are all processing millions of jobs per day. So that's a little bit the architecture. And then time for some bytecode. I think you may or may not know ASM. ASM is a library for bytecode reading, but we're all using it indirectly when you're using Hibernate or Spring because they embed it also. And so when we do background job.enqueue, and by the way, background job.enqueue is just a static helper that I once created. It's really nice for readability, background job.enqueue, but of course, being static, it's not so readable. It's readable, but it's difficult to test. But what happens when we have this lambda? Well, if you go to the class file, the compiler will create a synthetic method for that lambda. And why synthetic? Well, synthetic means it's a method that the compiler created. That's not something that you created. So the compiler created for you. And then it is, we have this synthetic method in the class. And here, what we do here, well, we get from the system class, we get the out property, which is in this case a print stream. And this print stream is then put on the stack. The next thing is, we have this string here. This is also put on the stack. And then here, the invoke virtual, that's in fact the method that we as JobRunner are really interested in, because that's the method where we want to run as a background job. So what does it do? It's the println method is called with, as an argument, the string that we earlier on passed on the stack. And that's all there is to it. You now already know how to read bytecode. If we make this example a little bit more difficult by background job.enqueue and then test service do work, some string, we do a counter, we do instant.now. These are all, these examples, by the way, are all part of our test suite. Well, what happens then? It's again a synthetic method. And what it does, well, we get the test service because we need a reference to it. And that's again put on the stack, and it's of type test service. So this is the fully qualified Java class name. Then the string is put on the stack. The integer is put on the stack. And for the instant.now, well, it's being invoked. So we do the compiler says, okay, instant.now, invoke it, and the result, it's an instant, that's also put on the stack. And last but not least, we are again interested in the invoke virtual method, which is test service do work. This is the actual lambda that is needed, being executed, and we have all the arguments being the string, the integer, and then last but not least, the instant. And this is how a class file, if you decompile a class file, and if you really go to the class, the bytecode, this is what's there. This is then later on interpreted by the Java virtual machine itself. But it's really not that hard. But I hear you now thinking, isn't this dangerous? Isn't this dangerous what we're doing, reading bytecode? Who is doing that? And originally, when I created JobRunner, I, of course, put it on Reddit and made a little bit of advertisement there. And there is this guy who responded, Your library may be nice at first glance, but there is so much black magic going on that you just should never be relied upon. And yeah, that's a comment that kind of stuck with me for a long time. So yeah, I started thinking about it, and then I looked and I found this is from the Wikipedia related to Java and compatibility. There are 3 types of compatibility: source compatibility, binary compatibility, and behavioral compatibility. And the part where JobRunner is hooking in, it's in fact the binary compatibility. And this part is defined in the Java language specification. And this is some of the things I really like about Java. Well, the Java language specification doesn't change that much, which means that it's still, in in a lot of cases, possible to run Jar that was compiled with Java 1.0 on Java 21, unless you're doing some strange stuff and the methods got deprecated and removed. But typically, we can still, all the Java code that we write, I didn't have to refactor a lot of things just for upgrading a GVM. So that's, I think that's okay. Then, because I wrote a blog post about how I test JobRunner on all the different GVMs, Oracle reached out, and they are, of course, maintained in Java these days. And I think they do a really nice job. And they said, hey, we saw that you're doing funky stuff with the Java and bytecode. Do you want to participate in the quality outreach program? And what does that mean? Well, it means that I get sent an email each time with all the changes that happen inside the upcoming Java releases, and they ask us to test whether JobRunner works on these new pre-releases of the GVM. And the screenshot is already a little bit outdated, but up until now, I never had any problems with Java and this part. So we still participate. We just tested on 24, which is okay, and 25 is already upcoming. So we should also write the test case for that. And how do we do that? Well, we have this one GDK test, and this is a combination of test containers, which is awesome, by the way. And what happens, I think you already know. What we do is we take a little bit of code where we use sanity check JobRunner. We copy it over in one of these GVMs, adopt OpenJDK 8, 11, Zulu, even GraalVM. And then we do MVN clean build, and we make sure that the output contains build successful. And if that's okay, then we know that everything is working fine. So I think it's okay. It's not too dangerous to use this, but the comment still kept on hanging to my head. And then suddenly I had an idea. And when I released JobRunner 4, I added a new feature, which is the possibility to create jobs using the job request and job request handler. And this is a little bit like the command handler pattern, where you just use a DTO, which describes your job, and then you have a handler which handles your actual job. And how does that work? Well, let's say you want to send an email. We have this DTO class, which is nothing more than send email job request. And the important part, it's 2 things. You need to implement the job request in this case. And this interface will force you to create this one method, get job request handler. And the handler is the class that will send the actual email. But I'll get back to that right away. But of course, we're now it's the year is 2025. We don't write any Java code like this anymore. It should be nothing more than this record, public record, send email job request, string 2 from subject, blah, blah, blah. And what do we do again? We implement a job request and we say which handler that should handle it. And then we have the job request handler, in this case, the send email job request handler. And that one, again, needs to implement an interface. In this case, the job request handler. And what kind of job requests will it handle? Well, it will handle send email job requests. And what does it do? Well, this interface requires you to implement one method, the run method again. And what then you do? Well, here we get as an input the send email job request. And we then can just type simple mail message, blah, blah, blah. We inject the Java mail handler using from Spring Boot. And we can just say, hey, Java mail sender, send. And the nice part is that if, for example, your SMTP server is down or Mailgun is down, well, JobRunner here in this case will automatically retry 2 times if for some reason that email wasn't sent successfully. And how do you use that? Well, really easy. And I'm sorry I didn't update the screenshots for CoffeeJug, but background job request.enqueue and then new send email request to info@CoffeeJug from Ronald. Hey, this session was awesome. I quickly wanted to thank you to share that I'm having a blast for the moment, and that's it. So it's really also easy to use the job request and job request handlers. So using all of this, we know what we'll need to do. We have the information in when it's lambda, we can analyze it, and we have here the thing that we need. Otherwise, with a job request, we instantly have it. And then what we do is, well, we convert it to JSON. Why JSON? Well, I like JSON a lot. It's easy, it's small. The previous one, sorry that I go over to this one a lot fast. This one is from really a long time ago. Now it's like this. So we have the job details. Whether it's cacheable, this is something for performance. Then we have the class name that we need to run, in this case, the test service, the method name, which method, and then all the parameters. And one thing that is important is that all your parameters should be serializable with either JSON, JSON, or JSONP. And another tip I want to give is try to not pass a complete root entity or something as a job parameter. No, pass the UUID or the ID of your entity. Why? Because otherwise you will have this big entity that will be serialized to the database, whereas it's a lot better to just have the ID, and then inside your job, using the ID, get your actual entity, which is bound correctly with Hibernate, the entity context of Hibernate, and that you can then use. So don't try to, you can pass in whatever you want, but it needs to be serializable by your JSON library. And my experience from the field, try to keep these arguments as small as possible. And why JSON? Well, it's for me about keeping things simple and stupid. It's readable, debuggable, and on top of that, it's really easy to use in the dashboard. Quickly checking the time, 10 more minutes, that's perfect. Then what do we do then? Well, then we save this inside the database. And the first thing that we do is we also save the MDC context to the job. And why is that? Well, remember there was no correlation ID originally when I created JobRunner. Well, let's say that you have a web request and you have a correlation ID that you create for every incoming web request. Well, that way the that correlation ID is also propagated down to the job. So that's part of the job, and we then restore it automatically for you, so that you in your logging you have the same correlation ID available. Then this is the job filter utils. This is a little bit like an HTTP filter where you can hook in when we create a job, so you can hook and add extra logic for when your job is created. Then we save it to the database or the NoSQL database. Then we say, hey, we successfully created the job. And we say we log something, and voila, we're done. If for one or the other reason you passed in your own idea, well, then we will not save the same job again because it already exists. So you can pass in your own idea to make sure that if you're listening, for example, on an event bus and you want to create jobs from certain messages on your event bus, that you don't create them twice. That's automatically handled with this. And then these are all the databases that we support. So I'm going to start with SQL, DB2, H2, MariaDB, MySQL. This is also an older screenshot, but MySQL is also supported. Oracle, Postgres, SQLite, SQL Server, and then NoSQL, DocumentDB, and Mongo. We decided to drop support for Redis and Elasticsearch in the next release because it was just too hard to maintain, and there are not a lot of people using either Elasticsearch or Redis, so we decided to drop it. And then on the server where the jobs are being processed, well, what is done? There is this thread that constantly checks, hey, is there any work that needs to be done? It checks for enqueued jobs. We have a look at how many jobs that we can run in parallel, because let's say that you create millions of jobs. Well, you don't want to have millions of jobs in memory because you then go out of memory. So we look at your system to see what's possible. We determine then the best amount, and this amount we check also which job, how many threads are already doing work, and then we have like a result. And if there is anything that we can do, if there is more than one, more than zero, then we get all the enqueued jobs using the work page request. And for all these jobs, we enqueue them and we say, hey, background job server, start processing them. And then what do we do to prevent that the same job, because it's distributed, is not being run by multiple servers at the same time? Well, there are two things that we do. In everything before JobRunner v7, we used optimistic locking. So the first server that was able to say, hey, I want to process the job, this job start processing on background job server, and then it could successfully save it. Yeah, that's the one that then could continue with actual processing. If not, yeah, then we have a concurrent job modification exception, and it means that the processing already started on another server, and in that case, this returns false. And now in JobRunner v7, we do something really cool, I think, to improve performance, and it's called select for update skipped locked. What does that mean is that we delegate responsibility for not giving all the jobs to the database, and it has a really nice performance improvement. That's that. And then we are going to process the actual job. So this is then a run method inside a thread. So what do? We notify that the thread was occupied so that we know how many other jobs can be onboarded. This is the method I talked earlier on about. We update the job state to processing, and we return if processing can start. If it can, yeah, then we continue. Otherwise, yeah, we're done and we wait for the next job. But if it can, then we run the actual job and we update the job state to succeeded and run the job filters again. Things can go wrong. Well, the job could have been deleted while processing. Well, then there's nothing more that we can do because, yeah, it's deleted. The server is stopping. Well, in that case, we update the job state to failed, and then we run the filters again. You could have changed your code, in which case we cannot find the job anymore. And then we mentioned it's not found. And any other reason that we have an exception, well, that's probably your fault, like the service is down, and then we say, hey, an exception occurred during the performance of the job. This is the message we saw earlier on in the dashboard, and we add the exception as a stack trace, which is, by the way, visible in the dashboard. I didn't show that, I think. And then at the end, we say, hey, okay, the thread is available again. So then the last part, the actual job processing, and that's nothing more than about a little bit of reflection. We get a class from the job details. We get we ask Spring or Quark as the bean. We get a method, and then we invoke it with the parameters, and that's all there is to it. This will then run the actual job. We store the job outcome then again inside the database, and this allows us to have this dashboard with this exception. And that's it. You now can build your own JobRunner if you want, or you can have a look at the GitHub repo, of course. All right, we're almost about to end. So where is JobRunner today and what is planned? So what I know, it's used for medical image processing, web crawling, order fulfillment, document generation, e-procurement, service desk automation, so much more. This number is not up to date anymore, but we have more than 300,000 downloads per month from Maven Central, and we process more than 1 billion of jobs per day. And then, yeah, I have 3 kids to feed, and this is, of course, all open source. So back in the day, I decided to create a pro version, which extended dashboard, more features. You have queues, batches, job saving, server tags, a lot more features. And yeah, that's the pro version. And I'm really lucky because thanks to this pro version, this is now my full-time job. And with the part of the revenue, we also do charity. What we do is we plant trees because I really think we should take care of the planet. And we have now, this is an old number, we have planted over, wait, I lost it. I think over 30,000 trees, and we also did 15 tons of ocean cleanup or river cleanup that we did recently. And then what is planned for the future? Well, we are also still looking into improving GraalVM. We support GraalVM, but I think then you need to use a job request. I would also make sure that it works with the lambda. We're currently working hard to make it faster. We're, of course, open for feature requests, and a big announcement I have to make also. We're currently working hard on JobRunner V8, and that will include carbon-aware job processing. And what does that mean? Well, if you have a job that is not time-critical, you can say, hey, I want to run my recurring job each night around 3 o'clock, and it can be, for example, 2 hours earlier, 2 hours later. It's not time critical, so I just need it to run that night. And what will JobRunner do? Well, we will search for the moment that the least amount of carbon will be generated, meaning that it will help our environment. And since we're now doing 1 billion jobs a day, and we see more and more usage for where JobRunner is used to train LLMs and update RAG contexts, which is all really intensive, CPU intensive, but doesn't always need to be the latest up to date. Well, that's an ideal use case where we can defer or plan the execution of the job where the least amount of carbon will be generated. We hope to release the first beta in the coming weeks, which has this feature. And then time for Q&A. Shoot, if you have any questions.
Yeah, first of all, thanks a lot for your presentation. Pretty good introduction and how to use into dive into details, how it works, like everything about that. So I think that someone who never heard about that will start using it, or at least at some pet projects, if or maybe even adopt on their like projects at work. Yeah, pretty nice, and thank you for sharing future plans. Yeah,
No worries.
interesting. And yeah, that's great that JobRunner trying to be more environment friendly. That's also pretty interesting, yeah, to hear. Not that frequent thing, I mean. And yeah, we have a bunch of questions.
Shoot.
Yeah, so I'll start one by one from the first one. And the first question, can I return a result from a job or specify a callback function when it's finished?
Good question. I like it. Yes, it's possible, but I'm afraid it's this is part of the pro version. And that's a little bit the difficult part with open source. Where do you put which version? And yeah, I've got 3 kids to feed, so I'm sorry that it's only available in the pro version, but it's possible.
Fair enough. Yeah. Let's go to the next question. And interesting question. Like maybe it's a part of next question. There should be a beginner. Yeah. So JobRunner has made distributed background job processing easily with Java, but how do you plan to keep JobRunner competitive as a cloud native, serverless, and Kubernetes native platforms like AWS Lambda, Google Cloud, etc. continue to evolve and reduce the need for traditional job queries? Wow.
Yeah, that's a really, really nice question. I love it. I think what we are also planning is to support even scale to 0 with JobRunner. And how will we do that? Well, we will have a method that just checks every once in a while, that just wakes up a little bit. Is there any work to do? And if that's the case, it will continue, it will spin up the server. It will not be for V8, but for V9. And the other thing is, at least that's my preference. I really like to have everything running as local as possible, meaning that I do not, except for my database with test containers is really easy. I do not need any specific cloud infrastructure. And we have even people that are going away again from the cloud because the cloud is also really expensive. I don't know if you know David Heinemeier Hansen. He is the creator of Hey.com. He was a big AWS customer, but just by moving to his own cloud, he was able to save 3 million euros per year. And that's quite a lot. So yeah, I think the cloud is nice, and we're fully supporting it because you can just have different JobRunner instances or different instances of your application containing JobRunner, and then you spin up extra pods, and they will automatically start processing work. But yeah, I don't know to answer. It's a good question, but I still think there is a need for this.
Yeah, and I can say it's pretty nice that JobRunner kind of embedded to the application, and no need to deploy it separately and taking care of that because it's together. It's pretty nice. Just start application and that's it.
Yeah, thanks for the nice comment.
And next question: can you plug in custom can I plug in custom filters, interceptors to modify job metadata or enforce policies before execution?
Yes. So back earlier on, when the job is created, for example, you can have a job filter or later on I named it job filter because of an HTTP filter, but it's in fact perhaps not the best name in hindsight, someone told me, but it's all possible. These filters are in fact interceptors where you can change the job, where you can hook in your custom logic.
Thank you. And this is a question from Stas. And next question from Mr. Mike. Interesting nickname. Sometimes I notice time delay before job actually started. How can I optimize it?
Yeah, that's a really good one. Let's go to IntelliJ. By default, we will only check your database if there is any work to do every 15 seconds. So it's waiting 15 seconds, and then we check, hey, is there any work to do? We wait 15 seconds, is there any work to do? But this is configurable. So what I can do here is using standard background job server configuration, static import, and poll interval, and here I can say duration of, and the minimum that we support here is 5 seconds. So then instead of waiting 15 seconds, you need to only wait 5 seconds. In the Pro version, you have instant job processing, but we do it in a different way because this adds, if you have like 40 servers or a lot of servers doing all of this, polling is not the best way to go. And in the Pro version, we solved it in a different way that you can, the moment that you enqueue a job, it starts processing.
Yeah, if it's critical for someone, it's one of the reasons to migrate to the Pro version.
Yeah. And give my kids some food then.
Thank you. And next question. Yeah, it's for me actually. During the presentation and the part about ACM library, since class file API recently added and publicly available in GDK, any plans to migrate to the brand new API?
Yes, of course. Yes. It's on our to-do list, but like always, we have 40 outstanding feature requests from our customers, but the plan is definitely to migrate to that. Yeah.
Nice. Next question from Andrei Leo. What about using virtual threads inside jobs? Any drawbacks of this?
Well, to be honest, we do it for you. You don't need to do anything. We check whether you are running on Java 21, and if that's the case, automatically all your jobs will run using virtual threads.
Oh, sweet.
So that's already done for you. The thing that we had two recent, I'm just saying it so that you know, that we had two issues recently, all unrelated to JobRunner, but related to the different database drivers. So they were then doing inside their jobs database calls. And these not all database drivers have been adapted yet. Postgres has adapted, so they also have support for virtual threads. But what you need to do, the database drivers, they may not use synchronized anymore. And some of them still do, and this results in thread pinning. And even we saw one case where there was deadlock because of it. So of course, this is like a setting I can using and where is it? It should be configurable here somewhere. Concurrent job modification, background job server, worker policy. Is it this one? Just a second. It's all configurable, but typically I use, it's here. So typically I use Spring Boot. Then it's just a property where you say whether you want to use virtual threads, yes or no. But here I can say 10, and then I can say, for example, the background job server thread type. And there I can say either platform threads or virtual threads.
Easy. So customizable. That nice.
Yeah. Of course.
Great. Then let's move forward to the next question again from Mr. Mike. You already briefly covered it with the future plans. Interesting, since it's working with bytecode. How is JobRunner compatible with GraalVM?
Yeah. So if you use the job request and job request handler, then we're completely compatible. And recently, GraalVM had support also to find out more. And definitely with the new job that you mentioned, it should be possible that we do everything also with the lambda. Beforehand. So we support it. I know plenty of users who are using GraalVM already, both Quarkus and Spring Boot. But use a job request handler in that case.
Yeah, good to hear that. It's also there's an option to use this GraalVM without limitations.
Yeah.
Nice. Next question from Frankie. Hi Ronald, I admire JobRun's impact and commitment. From giving 5% donation to environment cause. Yeah, that's nice. How did you come up with this idea? Was this initially, or I know?
It's from the beginning. I don't know how it was in Ukraine, but when I started JobRunner initially, it was one of the worst summers we had in Belgium, where it didn't rain for I don't know how many months. There was this new park in front of the house where we live. That winter they planted over 500 trees, and I think only 100 are left, so 3/4 died. Since I have 3 kids, I hope that they get an environment or a world with more trees in it. So that's why I decided, okay, I just want to give 5%. I don't care if it we can do all a little bit for the world, and if everybody does it, I think it would be a better place.
Yeah, really like this idea behind and appreciate that. Cool.
Thank you.
Next question is a football and engineering crossover. Hey Ronald, quick tech football mix. Big fan of what you have built with JobRunner. Also curious, as a fellow Belgian, what's your take on Romelu Lukaku lately?
To be honest, I don't know anything because I don't watch any sports. I prefer to do sports myself. So I won't be able to help with that, I'm afraid.
Yeah, let this question be open.
Yeah, indeed.
I would say this fun question was the last one.
Okay.
Yeah, that's all. At least from the live stream. But if you have any question, just put in the comments later below the video. Yeah, because I think someone can watch this video later after this live stream. And want to say thank you again for this great presentation. Nice discussions, Q&A session, in the end. Yeah. And
yeah. Again, thanks for having me. If there are any other questions, feel free. We have GitHub discussions also, so feel free to open a discussion there. There's one thing that we do ask, that is that you have like a GitHub profile that's a little bit explaining who you are, because GitHub is so anonymized. It feels strange to give free support to people that we don't know, so that's why we ask to have a little bit of info on your GitHub profile. But feel free to ask questions there, and if you like it, then you could always do us a favor by starting the repo.
For sure.
All right. Thanks again. And then I'm going to have my Belgian Pevo, I think it's called.
Yeah, Pevo, right. Hope next time maybe we can make it offline here in Lviv.
Yeah, definitely.
Okay, have a good day. Bye.